Okay, so here we're going to be doing some geometry of 2D shapes. Now, the geometry of 2D shapes is something that is very well known, which you've been introduced quite a number of times. But what we'll first do is to look through some of these shapes and talk about them quickly. Okay, so the first one is triangles. And with triangles, you have uh, these types of triangles. You first have the equilateral triangle, where all sides are equal and the interior angles are 60 degrees. We have the isosceles triangle, where two sides equal and two congruent angles. And then we have the scalene triangle, where no sides or angles are equal. You have the right angle triangle, where there is one right angle, meaning right angle means that it is 90 degrees. It has a 90-degree right angle, right? And then we have an acute triangle where all angles are acute. And when we talk about something that is acute, we are saying basically that that angle is in between 90 and 0. Okay, so it could be 45. And then we have another one here, which we call the obtuse triangle. And the obtuse triangle is where we have at least one of the angles being greater than 90 degrees, being greater than 90 degrees. So those are the triangles and the types of triangles. So the important thing here again is for you to know the properties, and knowing the properties will help you in solving the problems that we'll be facing ahead. So another one is quadrilaterals and regular polygons, right? Now, I won't go into great depth because it is written. So you can stop the video wherever you need to look at the properties and actually just see what's happening there. But you have the square, you have the equilateral triangle, you have the rectangle, you have the rhombus. Here again, they emphasize the square and the regular pentagon, and then you have the rhombus there of the parallelogram of the kite. You have the trapezoid and the trapezium. Now, the trapezoid and the trapezoid has two sides which are parallel, but with a trapezium, they have no sides that are parallel. And then you do see some other special types of polygons, where it's a regular decan, a regular octagon, a regular hexagon, a regular pentagon, and then the rest you already know, which is a square and an equilateral triangle. Okay, so these are the shapes that you should be able to just know and just know the properties of these particular shapes, because this is where most of the questions will come from. Okay, but before we look at a question, let's first talk about something what we call congruency. Now, congruency, the whole idea about congruency is that two shapes are said to be congruent if they are the same shape and size. That is, the corresponding sides of both shapes are the same length and corresponding angles are the same, right? So if you look at this particular triangle, you can see that they've already given us the sides of each of each side of the triangles, right? 7 centimeters, 3 centimeters, 5 centimeters. But you can also see that they did draw another triangle which they placed in a different manner. But when you look at the sides of these particular this particular triangle, you can see that they have equal sides: 7 centimeters, 7 centimeters, 3 centimeters, 3 centimeters, 5 centimeters, 5 centimeters. So whenever that happens, that's when we say that we have a congruent triangle in between them, right? Now, basically, there are many different ways of proving that. Or, I mean, there are many different ways of testing whether or not these particular triangles are congruent. So the first test that I'll talk about is what we say is the side, side, side test. And basically what you're going to do there, you need to find three sides that are equal to each other. So in this case, you know what this particular line means. It means that it's equals to that side. So 1, 1, this side is equals to that side. This side is equals to that side as well. And then the side is equals to that side. So you can see that in actual fact, the first test is that if all the sides of the triangle are equal to each other individually, then you do have what you call a congruent triangle. And this test is referred to as SSS, meaning side, side, side. Okay. And then we also have the second test, which is the side angle side. And basically, it's quite explanatory. Side, meaning that if we have one side that is equal to the other side, and we have an angle in the center that's equal to the other angle in the center with another side at the end, with another side, then we know that they are congruent. And remember what congruency means? It means that they are the same. They are absolutely the same via length and angles, right? And then we also have the third test where it's angle, angle, side. And with angle, angle, side, then we are talking about it having two angles inside, but with one angle being equal to the other angle, with another angle being equal to the other angle as well. Okay. And then we have a side that is equal to each other. Okay. And then we have the last one here, which is test 4, which is the right angle hypotenuse side, right? Now, the right angle hypotenuse side is mostly used for right angle triangles. So you'd say that it's an RHS, as you'd say angle angle as AAS, and side angle side as SAS. So here, what you'd look at is that if I have a right angle triangle for both of the triangles, obviously they are equal to each other. And then immediately when we talk about the hypotenuse, is that we have a triangle that is actually has an equal hypotenuse. And the hypotenuse, remember, it is the longest side. It has the longest sides being equal to each other and having a side that is equal to each other. So those are the 4 different tests. But there's something here that I think you should have noticed, that in actual fact, we did not talk about an angle, 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 right? But in that case, it is angle, angle, angle for similar triangles. Now, that is where we come in with similarity. Now, with similarity, shapes have the same shape, but may differ in size. So this is where congruency and similarity diverge, right? Similar angles or similar shapes, I'd say similar shapes are things where the sizes of those shapes are different. Now, when the sizes of those shapes are different, that means that they are similar. But how do you notice that they are similar? If you can prove that all the angles inside, or 3 of the angles inside the shape are equal to each other, then it's quite clear that they are similar, or they have similarity. They are similar and they have similarity. So in this case, you can see it's right angle, it's rectangles, sorry. So these rectangles, you can imagine we have 90 degrees for all 4 sides, and they also have 90 degrees for all 4 sides. And that is where I wanted to say, you must be careful to not think that if you're going to say angle, 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 you're proving congruency. No, you're only proving congruency whenever you say it's angle, angle, side. And when you're proving similarity is when you are proving that the angles in that particular shape, 3 angles in that shape, are equal to each other. And that would be sufficient to say that it is similar triangles, right? Now, another thing is that when we signify something being congruent, we use basically this side. We use this 3 lines going down like this to signify congruency, where you'd have a triangle, and triangle is congruent to each other, okay? And then when we talk about similarity, it's 3 lines going down. But we will see this in the example that we are about to do. So now the first example, the example that we're going to do is that study the diagram below carefully before answering the questions. It's a quadrilateral ABCD in a parallelogram, right? And then we have triangle BCE is a right angle triangle. And then the first question basically says, after looking at the diagram, there's A, B, C, E, C, D, and there's X, there's 34, there's 90 degrees. We have parallel lines, and we have a diagonal in the quadrilateral, right? Now, A, it says find the value of A, B, C. So where's A, ABC. So they are looking for this angle over here. Now they want to know what this angle over here is, right? So A, how can we solve this? Now with A, if you noticed, is that in actual fact, A with A, B, C, D, so A, the angle ABC is actually equals to the angle BEC plus the angle ECB. And what would that reason be? If you notice, it's BEC, which is BEC and ECB. That will give me ABC, right? So what's the reason for this? This is the exterior angles, right? This is the exterior. It's an exterior angles of exterior angle that is equals to it's the sum of the opposite, right? So it's equals to the sum of the opposite interior angles, right? Okay, a bit lengthy, but yeah. So the exterior angles, which are these ones, what are you looking for? Remember I mean, the exterior angle here is ABC, right? The one that you're looking for, and the interior angles are E and C there, right? So that would be how you calculate ABC, right? The angle ABC. And the angle ABC, basically, then you say it's 90 degrees plus 34 degrees, and you would find that your ABC is equals to 124 degrees. This is A, B, C. Okay, so that's how you'd find the first one. Okay, and then B says, now find the value of X. Now the value of X is here. You know this is 124 degrees. Now, luckily, if you know your properties of quadrilaterals, you would realize that in actual fact that X is equals to A, B, C. And where do we get this? Remember, I just said it's from the properties of quadrilaterals. If you know the shapes of quadrilaterals, then you can say that the opposite angles of quadrilaterals, of parallelograms, sorry, of parallelograms are equal, right? Are equal. Okay. So the opposite angles of parallelograms are equal, and that's why X is also equals to ABC, which is equals to 124 degrees. And then we have C. Now C, it says prove that ABC, and ADC are similar. Now, which of these triangles are this? This is ABC, right? ABC. And then we also have ADC. Now, notice something here, that we are trying to prove that they are similar. So what we're looking for basically is mostly the angles. We want to prove the angles that are being the same, right? So we already know that from B that in actual fact, this angle is equals to that angle, which is 124 degrees, right? Now we only need to prove this angle and this angle and this angle, that these two angles, these four angles, being that this one should be equals to one of the two, and the other one here, choose another color, and the other one here needs to be equals to another one somewhere there. Okay, so how can we do this? Now, what we can notice firstly is that one, we do have, if we look at the red angle, this red angle here, which is BAC. Now, BAC, if you notice, BAC is equals to ACD. Why? Because it is alternating angles, because we have the AB being the same to DC, which is something you learned in grade 8, alternating angles. And then we can also see that in actual fact, we do have that this angle here is equals to that one over there. And same reason again, you can say it's alternating angles. And so you already have that all three of the angles inside this triangle are equal to its corresponding angle in the other triangle, and therefore they are similar. So let me write this down. So in triangle ABC, and this is another very important part about this particular proof, or showing whether something is similar or congruent, is that you need to be able to write it out quite properly and quite clearly. That, okay, in triangle ABC and triangle ADC. Now, with everything that you've just written, you just said a triangle ABC. So you're gonna have to write all the angles of ABC on the left-hand side. So you say that the angle of ABC is equals to the angle of ADC, right? Which is something we shown here at B. And then that is proven above, right? Because you already showed it at B. So you could say, no, it's proven above. Okay. The second reason is that when we have BCA, then we can see that this is equals to ACD. And the reason for that is that we can see that BC is parallel to AD, which results to alternating angles, right? And then we have the third one here, and the third one is BAC, which is equals to ACD, and that would give you that we know that AB as a reason is parallel to DC, right? And then we also have the next one. Oh, so just before we conclude, just before we end, now we've proven that all three angles, these are three angles, are equal to each other from the corresponding triangles. Therefore, the angle not the triangle BCA, right? BCA is equals, or no, it's not equal, sorry, is similar to the triangle DAC. Now, this is also quite important. You need to follow how you have proven it at the top. So you started off with B, and then you came with C, and that was A. Therefore, you would name it as BCA. Here again, it's DAC. So the triangle will be DAC. Okay, so that's how we would name it, and that's how you would find that it is similar, and that is angle, right? The reason, angle. Okay. And then we have the next question, which would be the last question, and then the other three you try on your own, which is Deem, prove that ABC and triangle ADC are congruent, right? So how would we prove that they are congruent? So what we do is, which is D, if you notice that in triangle ABC and triangle ADC, we can see that one, A B C is equal, the angle ABC is equal to the angle, AB, the length AB, you can notice that the length AB is equal to the length BC, right? And that opposite sides of triangles are parallelograms are equal, right? Parallelograms, yeah. Won't write the full thing. Okay. 2, that you can see that BC is equals to AD, And basically you can see that this is the opposite angles, sides, opposite sides of parallelograms are equal again. And again, I mean, this reason here comes from the property of the shape itself, which is a parallelogram. So it's AC is equals to AC, and Y, it's common side, right? It's a common side within the bigger shape, which is the quadrilateral, right? Therefore, we can see that in actual fact, we have a triangle AB, right? ABC, we have a triangle ABC being congruent to the triangle DAC. And that reason is side, side, side. Okay, so definitely we were able to prove the congruency and the similarity of these triangles, which is not different from each other. We can find, and this is quite interesting that we can see this, that we can actually find that even if we are using the same triangles, we can find that in those same triangles, they can be congruent and similar to each other, right? But yeah, so if they are similar to each other, it's possible that they can be congruent, but it does not mean that just because they are similar, it will be congruent, because it could happen that they are not, right? Whenever the other triangle is bigger. Okay, so other than that, I'd like for you to try out E, F, and G on your own, and trying E, F, and G on your own, I think that would be good. And if you have problems with it, please ask your teacher or ourselves, and I'll be able to help you. Other than that, thank you, and I'll see you next time.